I'm going to show you what integration is in calculus, and we're going to do some basic integration rules as well. So the integration is a process of taking the antiderivative. It's the opposite of taking the derivative. So essentially, for example, let's say you were to find the antiderivative of u squared. Now, we're going to use the reverse power rule. And so basically, the reverse power rule basically states, so the integral of x to the n dx, where n is a constant, is equivalent to x times, you have n to the 1, n plus 1 actually, to the power of n plus 1, and then divided by n plus 1, plus the constant of integration. Because this is an indefinite integral, we cannot forget the constant of integration. The main reason is that when we take the derivative of this constant, we get 0. So that is in fact the reverse power rule. So now I'm going to show you some problems using like integration notation, integral notation. So to find the integral of cosine, you want to first know what cosine is the derivative of what function? Sine. So of course, sine x plus, you can't forget the constant of integration, c. And then let's talk about a few more. So we're actually going to get x to the 4th plus 2x squared plus 1 divided by x cubed, and then dx. Now, this seems complicated on first glance, but you can actually separate this entire expression into 3 separate integrals. So this will be the integral of, you can take, that's x to the 4th divided by x cubed, and that will be x with respect to x, plus we got, now of course, with constants, like differentiation, you can take the constants out of integrals as well. So 2 out of the integral, and then 2 integral of, we get x squared divided by x cubed is going to be x to the negative first. So that's the same as 1 over x dx, plus we get 1 divided by x cubed. But I'm probably going to write it as a negative exponent right now. So therefore we got 3 separate integrals. So if you do the reverse power rule here, we get x to the power 1 plus 1 is 2, and then divide by 2. So that's going to be 1/2 x squared, or x squared divided by 2, however you put it, plus 2. Now of course, if you try to do the reverse power rule here, you get x to 0 divided by 0, which is going to be an error here. But definitely 1 over x is also the derivative of the natural log. So the natural log of the absolute value of x. Plus, and then we get, then that's going to be negative as we're dividing, and then x squared. Okay, so it's actually going to be negative 1 divided by 2, x squared, plus the constant of integration. So those are some general rules here. Now, there are going to be more complicated integrals here. So let's say we have a square root of u plus 7 du. Now, of course, the variable is just a variable here, so you can treat the u and du as x and dx in this case. So we got u du. That's going to be very important because we're going to integrate with lots of variables, because we're going to do it in like finding areas between two curves. So of course, we're going to have to use u substitution for this one. Now, of course, we're gonna cover u substitution, but to tell, this one requires u substitution. I'm gonna put u sub but you get the idea. Next you want to, let's say, integrate expressions like these. You have x to the 5th times e to the x dx. You have a product of two functions, and you want to integrate them. There is no like product rule for integrals, so the next thing you can do is think about integration by parts. And that's going to be it. So now, let's say you also have a x squared then minus 9 dx. Now, of course, if we try to use u substitution, now, of course, this is actually not possible here. Again, if you don't know what I'm talking about, it's going to make sense in the next video because we're going to talk about u sub again. So this one can be solved using trig substitution. And that will be in the video after integration by parts. After trig sub, trig sub is in fact a very large topic. So if you say this, so we have x squared minus 4x minus 5 divided by, you got x plus 3 dx. Now this can actually be solved using long division. And now what I mean is polynomial long division here. Next, of course, in order to solve, let's say, this problem, like x divided by x squared minus 1, you could also use u sub here. But let's say you have an x plus 3 here. This can be solved using the separation here. And then I'm going to think of an example that uses partial fractions now. Okay, so we got the integral of, we get 2x divided by x cubed minus 1 dx. This one, we're going to use partial fractions. And technically, completing the square would also go into the trig substitution. And finally, a reference that will allow to solve definite integrals, not just indefinite one, or is that you have the FTC, the fundamental theorem of calculus. Yeah, so that part 1 is in fact going to be the hardest part. So if g of x is equivalent to, you have the integral of a all the way to x of f of t dt, then g prime of x, the derivative of g, is going to be f of x. And that's part 1. Part 2 is what we're most likely going to be using here. So it's saying, for example, the antiderivative. So let's say we're going to denote like f prime of x dx from a all the way to b. That's going to be equivalent to, we got f of b minus f of a. And that's pretty much all we're going to need before going into the next video. So u sub, integration by parts, trig substitution and completing the square, long division, separation of terms, then partial fractions, and then we're technically done with all this. Then we're moving on to applications. Oh, one more thing. Improper integrals. An improper integral is an integral which has either an infinite or non-existent bound. Like, for example, an improper integral could be, let's say, you got 1 over x plus 2 all the way from, you get negative 2 all the way to infinity. In this case, we have 2 undefined bounds here. But that's going to be a video for a later time. But anyway, guys, that's actually going to wrap it up for this overview of integration. If you enjoyed, leave a like and subscribe. See you in another video.